Good morning students. This is 8085 square root of number. So square root of 8 bit. So now I am taking on 8 bit data, that is move immediate a comma 25. Move immediate a comma 25. This is the 8 bit data to find the square root of 25. So the meaning is to find square root of 25. So this is 8 bit data. The next line, move immediate c comma 01. So this is the C register to get odd numbers only. So it will get, this is to be get odd numbers for subtracting content of A and the odd numbers. So what are the odd numbers? Are there 1 comma 3 comma 5 comma 7 comma 9 likewise. So the C register, it will get only odd numbers. So one more register is the move immediate E comma 00. So here the E register E is for counting, that is a counter number of times the subtraction will be done. So number of times subtracted, number of times subtracted. So the E register will be counted, how many times it is subtracted, comparing 25 and the odd numbers. Next, subtract of C. Subtract of C means that is A equal to A minus C, the content of accumulator, and subtract with the content of C, that is odd number. Then check the condition, jump carry over, that is if A is less than C, A is less than C, then A is less than C, then go to over to call the label here. When the condition becomes true, that is A is less than C, or the condition is false, the next instruction will be executed. So what is our next instruction? That is IN or E. So that is else condition. For else condition, E equal to E plus 1, that is the counter, the first time the subtraction is done, so the E register E will be incremented. And the same thing, C register also incremented, because the next odd number is, first odd number is 1, the next odd number is 3, so 2 times it will be incremented. So C equal to C plus 1, another time, that is the first time 1 plus 1 is 2, it is a even number, so one more time it will be incremented, so C equal to C plus 1. So now C register becomes 3. Then again jump again, because the condition is false, so jump again to subtracted. What is the condition? A is greater than C, because A is less than C, it go to over. So A is less than C, but A is greater than C, because the A is 25 and the C is 1, so A is greater than C, so it is subtracted and increment E, and shall as increment C register, so jump again. So second time will be subtracted. So again the counter will be incremented by 2, that is e equal to 1. Before e equal to 1, the one more time is subtracted, so e plus 1, so that is 1 plus 1 equal to 2. Same thing, the odd number will be incremented. The next odd number is 5. The next odd number is 7. Likewise we can subtract whenever the condition becomes true, that is a is less than c, jump over, move a comma e, that is counter e, that is how many times it is subtracted, that is the answer of square root. So square root number of 25, so that is to be moved on accumulator. Then the accumulator content is stored on C040 for the memory location. Then finally your program is alt, that is HLT for stop. Then assemble it. So it is directly converted to mnemonics and then hexacode, bytes, machine cycles, then T states. So now I execute step by step. First I put the data in accumulator for 25. The next C is 1, that is a move immediate, 0 equal to 1, the first odd number, initialize the C register. The next subtract C, because 25 is, that is pointed out in accumulator, so A is greater than C. Okay, so the condition is false, so condition false means it is subtracted, so subtracted first time, so 25 minus 1 is 24. Same thing, increment by E, that is 0 equal to 1. So here you see that before E is 0, now the first time subtraction will be done, so immediately E will be incremented. So next INRC for first time increment, INRC for second time increment, so that's why it got a odd number for the second subtraction. Now it compared 24 3, 24 is big compare with the C, so it is subtracted. So 24 minus 1, so 24 minus 3 is 21. So again increment by E, so that the second subtraction will be done, so E is incremented. The next the odd number count is incremented, that is INRC and then INRC, so 3 plus 1 is 4, 4 plus 1 is 5. Now it is subtracted 21 minus 5, so what we'll get, that is 1C, because it is hexadecimal number, it's not a normal number, decimal number. 25 minus 21 minus 4 is 19, but here is 19 is nothing but 1C. Okay, next E is incremented. Likewise you can subtract whenever the condition becomes true, that is A is less than C, whenever it reaches A is less than C, that is 6 times will be counted. Now the condition is A accumulator is 1, then register C is 0C. Now the condition becomes true, then go to over. So here go to over, move A comma E. What is our E? Current E is 06, that is a square root of number, that is copied on to accumulator. Then the content of accumulator is copied to memory, that is C040. Our specified memory location C040. For the 0th position it will be stored. So finally to stop the program, or directly run all time get the result. So this is A085 square root of a number. Okay, the next go to notepad. So here some exercises are there for to find what is the square root of the given 8-bit data. The first data is 36. So this is one of the 8-bit data. To find square root, okay, next second data 99. So this is another data to find square root. The next third one FF. So this is the third data to find. So these are all the some 8-bit data to find square root. Okay, thank you. So any doubt, please contact me.